Kita bareng jalan. Jauh. Ừ. Good morning, sir. Mahesh sir, good morning.
Namaskar. Good morning, sir. Good morning.
How are you, sir?
Good morning, Ilandu. Surya
Surya
Prakash.
sir, good morning.
Good morning, good morning.
Good morning to all.
Good morning, sir. Maheshwari, sir. Good morning. Good morning, sir.
Good morning. Good morning.
Vallabhan sir, good morning. Priya.
Yes, sir. Good morning, sir.
Am I audible?
Yes, sir.
Okay, everything is set ready?
Yes, sir. We are ready.
Yeah, we'll wait for 5 minutes.
Yeah. Sir, actually, what we were talking is repeating again.
What?
Sir? Hello? Sir, am I audible, sir?
Yeah. Yes, audible.
Okay.
My voice, my audio,
Yeah, yours is
clear?
Hello. Hello. Rajesh Maheshwari, sir. Am I audible, sir?
Audible.
Yeah. Shall we start, Priya? Yeah.
Yes, sir. Yes, sir.
Yeah.
A very good morning, ladies and gentlemen. A warm welcome to the 5 Days National E-Faculty Development Program organized by Tagore College of Pharmacy. It's an honor to have esteemed speakers, faculty members, honorable principal, and organizing members and professionals to join us today to explore the evolving relationship between industry and academia in pharmaceutical research and education. I'm Dr. Priya.
Volume is not audible. Please take a feedback. Myself, Dr. Anbalagan, Principal, Kalam College of Pharmacy. I could not able to hear the voice.
Am I audible, sir?
It's audible only.
It's audible. It is audible. Very clear.
You are audible.
Ambulance, sir, check your audio. Ambulance. Yeah, continue, Priya.
Yeah, I'm Dr. Priya, Professor, Department of Pharmacology, TCP. It's an honor to kickstart this event and witness the exchange of knowledge and insights among the experts in the field. Thank you all for joining us today. So, to commence this prestigious event, let us begin with the inaugural address by whose endless commitment made this event possible. He is none other than our Honorable Principal, Dr. K. Ilangu, sir, with 3 decades of experience in teaching and research in the field of pharmacy. Over to you, sir.
Thank you, Dr. Priya. I'm audible?
Yes, sir.
Yeah, sir.
Yeah. Good morning, esteemed guests, distinguished speakers, faculty members across the country, and dear delegates. It is my great honor and privilege to extend a warm welcome to all of you for this National E-Faculty Development Program 2025 organized by Tagore College of Pharmacy. We are all gathered here on this esteemed platform to embark on a 5-day journey of knowledge exchange, professional development, and collaboration under the theme of the FDP, Bridging the Gap, Industry Academia Partnership in Pharma Research and Education. The objectives of this faculty development program is mainly to enhance the domain-specific knowledge, strengthen core competencies, and encourage research initiatives that contribute to the progress of pharmaceutical sciences. We are honored to have an exceptional lineup of renowned speakers from both academia and industry who will be sharing their expertise on topics ranging from regulatory affairs, artificial intelligence in pharma, innovative drug formulation, entrepreneurship in medical device, and advanced pharmaceutical manufacturing technique. Their insights will undoubtedly provide valuable perspectives to enhance both teaching methodologies and research contributions. So, at this juncture, I take this opportunity to express my thoughtful gratitude to our Chief Patron, Dr. M. Mala Madam, Chairperson, Tagore Group of Education Institutions, and patrons, Mr. Sri Manigandan, Secretary, conveners, organizing secretary, event managers, and all faculty members of Tagore College of Pharmacy for their dedication and efforts in making this event a reality. A special appreciation to all the participants who have joined us from various institutions across the country. Your enthusiasm and commitment to learning are what make this FDP truly impactful. So, we have the program for 5 days. We have selected the guest speaker across the country from both academia and in industry. So, all are eminent in their field and their profession. I thank at this juncture to accepting your invitation to be the guest speaker for the 5 days. And there are delegates across the country join not only at junior level. I can see many registration at principal, professors, senior professor, associate professor, assistant professor. That shows the success of this FDP. Today we have 2 sessions, 10 to 12. We have with us in the morning session, senior most professor, Dr. R.K. Maheshwari sir with us. Thank you, sir, for accepting our invitation to be the guest of today's session. And then Rajesh Khanna from industry. I welcome both of them for this today's section. And let us make the most eventful platform, engage meaningful discussions, and take forward valuable insights that will not only shape our careers, but also contribute to the advancement of pharmaceutical sciences. So I thank all the principals who supported. I can see many principals joined with us. And I welcome Dr. Vallibhan sir also. He is one of the speakers on 20th. Thank you all. Thank you for joining with us today and make this as a very useful and fruitful for your career development. Over to Priya.
Thank you, sir. Thank you so much. So without any further ado, let's move on to our first scientific session of the FDP. Now, I'd like to call Ms. Sri Lakshmi, Assistant Professor, to introduce our first speaker of this 5 days National FDP.
Morning to all present in the virtual platform. I take immense pleasure in welcoming Dr. Rajesh.
It not audible.
Sir, am I audible? Sir, am I audible?
Sri Lakshmi, little louder, please.
Yes, am I audible now?
Yeah, audible, little bit louder.
Okay. A very good morning to all present in this virtual platform. I take immense pleasure in welcoming Dr. Rajesh Maheshwari sir to this 5 days National e-FDP program. Sir is currently serving as Professor, Department of Pharmacy in Sri GS Institute of Technology and Sciences, Indore, India. Dr. Rajesh Kumar sir completed his Bachelor of Pharmacy in 1979 and Gold Medalist in Master of Pharmacy in 1981, both from Dr. H.S. Gaur University, Madhya Pradesh. He earned his PhD in Pharmaceutics in 2008 from the School of Pharmacy, Devi Ahilya Vishwavidyalaya, Indore. With over 3 decades of teaching experience, he has significantly contributed to both undergraduate and postgraduate pharmacy education programs. Sir has guided more than 80 candidates in undergraduate and postgraduate, and Sir has guided 3 PhD scholars. Sir is also life member in various associations, notably Indian Society for Technical Education, New Delhi, Association of Pharmacy Teachers of India, Bangalore, and Indian Pharmaceutical Association. One of his notable contributions to the pharmaceutical science is the development of mixed solvency concept. This innovative approach put forward that every substance possesses solubilizing properties, enabling the use of various solvents to enhance the solubility of poorly water-soluble drugs. This concept has paved the way for more eco-friendly and efficient drug formulations. Sir has published over 6 books in the year 2012 regarding the mixed solvency approach. Sir has authored more than 180 research publications and presented more than 150 papers in the conferences. In 1975, Sir secured a certificate of merit from the Ministry of Education and Society Welfare, Government of India, on the basis of high position in higher secondary examination. Sir was awarded with Indian Drug Manufacturers Association Best Research Paper Award in the year 2005 in the discipline of pharmaceutical analysis. Sir was honored with Eminent Researcher Award in the year 2012 by Association of Pharmacy Professionals, Bhopal. Today, Sir is with us to enlighten our knowledge on the topic eco-friendly and economic applications of solubilizing properties of safe and economic solids in various fields of pharmacy. We once again welcome you, sir.
Okay. Good morning to all of you. Firstly, I would like to thank Dr. Elango and of course Dr. Saravanan, because of whose efforts I am here with you to share some new research ideas in the field of green chemistry. My lecture is based on solubilization, and in this lecture what you will get is that we can do a lot without the use of harmful organic solvents. So before sharing this PowerPoint presentation, I would like to explain something to you. I have started very new concept known as mixed solvency concept, first time in the universe in the year 2009. There are 2 parameters of this mixed solvency concept. Number 1 parameter says that each and everything present in this universe has got solubilizing property. Up to this time, you will not find these things in the books. Up to this time, what do we know from the literature or from the books is that whatever are the substances which exist in liquid state, they all are known as solvents. For example, water, ethanol, methanol, chloroform, and so on and so forth. So only we see the liquid substances which are present at room temperature in liquid states, we see them as solvent. But today you will listen some new things from me, that not only liquids but also the gases and solids, they also possess solubilizing properties. But only thing will be the molecules of gas or molecules of solids should be in liquid state to demonstrate their solubilizing power. In mixed solvency concept, all molecules present in this universe are known as solubilizers. For example, you see, in case of liquids, water is solvent, but we know that water is solvent, but water is not solvent for each and everything. It is not good solvent for each and everything, because we know that 1/3 drugs, they are water soluble, 2/3 drugs, they are water insoluble. This means water is good solvent for some compounds, for example, 1/3 drugs, and water is bad solvent for others, for example, 2/3 drugs, like that. So if you take the name of chloroform, although it is known as solvent, but that chloroform possesses good solubilizing properties for some solutes and bad solubilizing properties for other solutes. Means some compounds are highly soluble in chloroform, other compounds, they are insoluble type in chloroform. So whatever the name of any solvent you take, that solvent possesses good solubilizing properties for some solute and bad solubilizing properties for other solutes. Similarly, all molecules present in this universe which are known as solubilizers, but only thing will be whatever the name of any solubilizer you take, that solubilizer will possess good solubilizing properties for some solutes and bad solubilizing properties for other solutes. The new things which you will listen in this lecture, they are that means you want to have proof that how can we say that gases and solids possess solubilizing properties. I will give few examples of gases and then I will focus on the use of solubilizing properties of safe and economic solids to replace harmful organic solvent. So, for example, I'm giving the example of gases. In supercritical fluid technology, we know that CO2 gas, after liquefaction at particular pressure and temperature, is being used as solvent to prepare nanoparticles for extraction of active constituent from herbal powders and so on and so forth. But liquefied CO2 is in this way, liquefied CO2 is acting as solvent. But this liquefied CO2 is also not good solvent for each and everything, because we know that sometimes to improve the solubilizing properties of this liquefied CO2 in supercritical fluid technology, you are supposed to use other co-solvents, ethanol, methanol, etc., to improve its solubilizing properties. So for such type of substances where you require co-solvent, for such compounds, liquefied CO2 is poor solvent. So now you can say that liquefied CO2 is good solvent for some compounds, bad solvent for other compounds like this. Anyway, mostly I will give the examples of solids in my lecture, and we will see the utilization of solubilizing properties of solids to replace harmful organic solvents. So before, of course, starting the sharing of this PP presentation, let me explain you what happens in dissolution. Simple mechanism of dissolution is this, that suppose you dissolve, say for example, sodium salicylate in water, sodium citrate in water, we get clear solution. How do you get a clear solution? The dissolution of, say, sodium citrate in water takes place as a result of weak van der Waals forces and hydrogen bonding between the molecules of sodium citrate, solute, and molecules of water, means solvent. So always there is a physicochemical interaction between the molecules of solute and molecules of solvent. Okay, suppose you are dissolving ibuprofen in chloroform, you get a clear solution. The dissolution of ibuprofen in chloroform takes place as a result of physicochemical interaction between the molecules of ibuprofen and molecules of chloroform. Now, what I want to tell you means similarly, now, for example, you see in supercritical fluid technology, CO2 gas, after liquefaction, the molecules of CO2, they are in liquid state, and these molecules of CO2 which are in movement in liquefied CO2, they are associated with hydrogen bonding and weak van der Waals forces with the molecules of solutes for their dissolution. So always for dissolution, there is physicochemical interaction.